Yesterday, what did we talk about? How to find lengths of chords. Now what about secants and tangents? All right. If I ask you to find the length of a secant or a tangent, here's exactly what we're going to do the entire time. And it's just a little saying. Whole, and I'll show you what each means in a second, times external equals whole times external. What does he mean by that? And this is for tangents and secants only. You guys know what to do with the chords from yesterday. Yep. All right, whole times external equals whole times external. Thanks. Look at the diagram. What are these two up here? Identify them. Don't say a word. Identify those two. 13. Nope. 4. What are those? Perfect. They're secants. Take one of them. Ready? Whole secant. Name it. Name a whole secant up here. CA. So CA times, what do you think I mean by external? The part on the outside, which would be? Okay, you guys are picking this up. So CA times BA will be the same as, go to the other whole secant. EA times DA. Whatever those values are, I multiply together and set them equal to each other and solve. Whole times external equals whole times external. Everybody good? So there's two secants. What if I throw at you the next diagram? Oh, buddy. Okay. This could be huge too, because this would be no homework over the weekend, because I have it due on Monday. Star. Clock. 3, 4, 5, 6. 4, 5, 6, 7, 8, 9. Okay. Curtains. Hey, you might, be the person who's going to vote, because it may be your one vote and it comes up you and you can stand up and be like, yeah, what now, right? Yeah, exactly. Yeah. Curtains. Any slides? Fades. Just going to fade out. Cube. 2 cubes. Shatter. Flip. Genie. Pinwheel. I'm going to go a pinwheel too. All right, I think so. Page curl. Okay, here you go. Clock or Promethean man. Clock. And we all know clock, it'll go around, right? Okay, here you go. Clock or Promethean man. Here you go, everybody. Here we go. Ooh, a little spin, I guess. We don't have that one up there. We got to probably add that one, huh? That's not, no. No. I will go backwards, though, all right? Here we go. Let's get going. Little fade. Okay, now I have a secant. Now I have a secant and a tangent. Doesn't matter. Whole times external. Give me the whole secant. dB times the external part. CB. Oh, let's see who's on their toes now. Let's go to the tangent. And again, we're measuring the part from the point of tangency to the external part. All right, so this would be whole tangent, AB, and what do we know about its external part? It's the same, right? Both the whole tangent is on the outside. So if you really wanted to be clever here, anytime you're dealing with the tangent, it would just be itself squared. Yep. Now I have one question you're going to help me answer. I'm sitting here and I'm thinking to myself, okay, this guy just did 2 secants. He just did a secant and a tangent. Why is there no diagram for 2 tangents? That's the party hat. What do you know about them? They're congruent for tomorrow's quiz. Nice job. There doesn't need to be a rule. They're congruent to each other. All right, so let's do this. Find the value of each variable Answer's not a whole number, round it to the nearest tenth. First diagram, what are those two? Two secants, and I'm looking to find the measure, so whole times external equals whole times external. So here we go. Pick one secant only. Let me know the whole length. 16, let me know the whole length. 15, good. And what about its external part, Maggie? 5, perfect. I shouldn't have put, now I'm going to put equals, sorry. Equals, now go to the other whole secant. Ooh, 10? You're adding them together, not multiplying them. 4 plus x, and what about the part on the outside? 4. Coming off of yesterday, it's very, you know what I usually see from students coming off of yesterday's class? What they do when they see this. 5 times 10 equals 4 times x. That's only for what type of segments? What did we do yesterday? Chords. That's only for 2 intersecting chords. All right, when you have secants and tangents, you got to do whole times external. So we have 75 equals 16 plus 4x. Go ahead and move the 16 over, divide by 4, and if it's not a whole number, which it doesn't look like, but round it to the nearest tenth. And when you're ready, round it to the nearest tenth. We're looking at what, 16? 14.8. Next, what are they here? What do I have here? What's in my diagram? 15, what's in my diagram? Whole times external. Ready? Give me a whole secant. 9. Whole secant. What's the whole secant length? 11 times its external part. 2. Okay, let's go to the tangent. Whole tangent length. 12, whole tangent length. Y times itself, because that's the part on the outside, so it's going to be y squared, equals 22. And just need it rounded to the nearest tenth. Ten rounded to the nearest tenth. 4.7. No, Sean? Okay. Are we all right? Whew, all right, here we go with this next one. Yeah. What are those, first of all? I always try to figure out what they are. 6. Secants. All right, can you give me a whole secant length? Either one. Okay, 8 plus y. Everyone, that's the one on the left. 8 plus y. What times its external part, Nick? 8. Okay, that takes care of that one. Ooh, be careful. One on the right. How long is the whole secant on the right? 11? Y plus 10. Nice job. And what's the part on the outside? 7. This one should be a whole number, right? Three. What do we end up with? Y equals? I think you're wrong. It's okay, though. It's okay. You're going to learn from it. Hey, ready? You move move the 7 over. Okay. It happens, right? It happens. You'll have redemption soon. You'll have redemption. All right. Just like we can have big dog circle questions for angles, we can also have it for lengths. And that's what this one is. We have an X and you have a Y here. I don't know where you want to start or where do you think you can start. Because what do we have in this diagram? We got a tangent. We got a secant. We also have what in there? Chords too. Yeah, we got it all. We got it all. I will let you guys know there's only one variable you can solve for now. You cannot solve for the other one. If you guys are trying to do whole times external on the tangent and the secant, you're going to run into a problem. Watch, ready? Here's your problem. The tangent would be y times y, right? Which would be y squared. But then you go to the secant, and what's involved in the secant? An x. That's not going to fly. A y and an x. So let's get off the whole trying to find y, and let's find x instead. And you're probably thinking, well, don't I run into the same problem? An x and a y? No, you don't even need the y. Ready? Hey, take a look. What are those right now? Two intersecting chords. Two intersecting chords right there. And from yesterday, somebody give me two pieces of one chord now. 4 and x, so 4 times x equals, what are the other two pieces on my second chord? 10 and 3.2. This is what we did yesterday. Four x equals 32. I'm just going to ask anyway, hopefully. A little redemption. 16? 8. So now you guys know it's 8. Now we can find y, which is a tangent. So I'll start you out. Y squared equals, all right, going back to the board, 16 again. What is the whole secant length now, Maggie? 18. Okay, everyone's seeing where Maggie's getting 18 from. 4 plus 8 plus 6. The whole secant length times its external part. 18? 6. Y squared equals, oh boy, 8, carry the 4, 108. Yeah, 6 times 8 equals 48. 8, carry the 4 up. And nearest, we'll keep going the directions, nearest 10th. Oh, redemption, I knew it. I knew it, 3. It knows. $10.4. Okay. I don't think we're going to have enough time to finish this next one because I know what it involves, but we will pick that one up on Monday then. Okay. So again, homework is due Monday, along with your review problems that I assign tomorrow night. They're right out 54 big circle ones, yes. I don't know how many are left, but I can always copy more if anybody wants to stop by later on today.